Right. So we've got two things going on here. First of all, I put my scope up there because that means it's up and out of the way, so I can get access to things. So I can basically leave it permanently up there, which is actually pretty good. And the second thing is I'm trying to organise basically how to visualise the plots against the graph. So it has the ability to basically add dotted lines and an image and stuff. So I'll put them in as well, which is also interesting. Anyway, so what I've done with the code, right, is I've actually added where it keeps changing between maximum and minimum, and then 50% roughly, right, on all three outputs. Although the 9 is going to be different. Ooh, yeah, that's different. See, that's wrecked it completely now. By putting that one in there, it's actually trashed it. So I don't know how. Because what I've got is I've got the trigger. I'll 0 it. There we go. I want the trigger level so that it stops flicking around, and that's as near as I'm going to get, I think. So we're looking in the middle here, obviously. And what's happening is every second it changes. So what I'll do is I'll stop it on hopefully 1, 2, 3, stop. There we go. So what we've got here obviously is the can I actually change the scale now? Oh wow, I can. Let it run. Right, so this is, I don't know which one it is, but obviously this is spending all its time high and it's clicking low, so that's the 254, the first one, right? And so what's happening here is, you can see actually we can use this diagram here, right? So the blue line is this test point here, it's the output, right? And then we've got the green line, which is the low side, and the orange line is the high side gate, and the yellow line is the logic input. All right, so blue line, this one here, is the output, which is going between 12 volts and 0 ground, because we've offset all of the, except for that one, we've offset everything to -3, as you can see there, -3, -3, -3, and this one's at 0. So all of the output lines are there. Right, and then we've got some are on 5 volts obviously, and some are on 12 volts. So we've got here, anything heating up? Just checking to see if anything's heating up, because I can smell something, but it's probably just my heater. There we go. So what I'm doing is I'm basically just trying to tune this circuit, and then we'll go on and tune the rest of them. Right, so the green and the orange. So the green one is the low side gate, which is going up to 5 volts and then down. Okay, and then we've got the orange one, yeah, which is the high side gate, which is coming down from 12 volts, right? Right, this is on 12 volts, and it's coming down from 12 volts to turn it on, and then going back up to 12 volts to turn it off, because that one's pulling the line high. So this one is spending all its time turned on, which means that the output line's pulled high. So there we go, and we're trying to get the timings. So the yellow line is obviously the input line, and the blue line is the output, right? It's on 2 microseconds here. So we're actually completing a switch, it seems, in about 2 microseconds, which isn't great, you know, but the actual swing looks like it's happening very quickly. So I don't know, doesn't matter anyway. But we can see this one is going up at an angle. Right, now the orange one is the high side, which is still the slowest one. Well, yes it is, because that's what's going on. It is the slowest one. We can maybe stick an extra resistor in there or something, I don't know. But it's still the slowest one, but okay. were happening where basically the switching is happening within, on this one, is within 2 microseconds. Now that's the switch off, because this one is now switching off, so it's going from on to off, which means that line is then going, the blue line is going from high to low. So this is on, and then it switches off and lets the line go low, you know. But these are all cold, so it's obviously very, I mean, it's not very high. I mean, we're talking about 1 kilohertz, right? And this is 1 microsecond. 1 kilohertz is in the millisecond region, right? So these are happening once every milliseconds, right? So we've got 1,000, 1,000th, or in this case 2,000ths, so 1/500ths, you know, of the full cycle. So 0.2%, isn't it? 0.2% is spent in transition. So yeah, they won't heat up until we actually stick a motor on it, and then maybe things will start getting warm. Right, now if we let it run, and then we can get some of the others. Right, so we got that one. There we go. Is that the one that I just done? Yeah, I think it is, isn't it? We need the other side, the one where it's that one. There you go. Now this is the other way, where it's spending all its time off and a small time on, right? So we've got the opposite happening now, where basically this line is held low, which means the low side one is going to be turned on most of the time, right? Oh, it just keeps switching between them, doesn't it? Right. So the blue line's the output, so it's going. It's obviously following the input, and we can see here it's the switch again. It's that bloody high side one that's causing the problems when it switches off. Everything else is nice and fast apart from that. So it's working the same way, basically. We're saying it's working the same way. I think we've got this one because there's actually something happening on another channel, which is causing weirdness. Funny noise there. Right. And then what I want to do is try and capture the one which is in between them. That one. Okay. Some funny noise going on. So we can see here, oh, it's actually because it's fired onto that, hasn't it? That's what it is. Right. And so what's happening here is we're seeing the same thing happening. Okay. Where it's, and I'll let it go the other way because I want to catch the other side. Yeah. Ah. Yeah, there you go. I think. I don't know. Yeah. But what I'm trying to do is make sure that it's responding the same way no matter which bit, and we're really focusing on that sort of bit in the middle, you know, and we're trying to make sure that it's doing the same thing. It doesn't matter where it is. Specifically, we want to make sure that the timings are the same and that the levels are the same. Yeah. Let me see if I can mess around with that trigger level. No. Yeah. No, it's not going to work. I need to change the kind of trigger, I think, don't I? Let me see. Hold off. 10 seconds? No. Here we go. Hold off for, yeah, 1 millisecond. Try that. No. And then we'll set the level. No, I don't think that's worked, does it? Let's try again. Hold off. One microsecond. No. Just hold off for about 10 microseconds. Should be enough. Yeah, there you go. No. Yeah, I don't know. Anyway, there you go. Not quite sure what that's supposed to help with, but there we go. Let's just be a bit higher. Well, that's done it. There we go. So that's a bit more stationary now, isn't it? We're only getting the one side, and then if we switch the slope, yeah, then we see the other side. Yeah, that's better. Yeah, and the one we're interested in is the blue line, because that's the actual output, and that looks okay. And so now I'm going to go ahead and tune the other channels the same.